In this video, I would like to present the definition of a function, which is here on the board beside me, and look at some examples to begin to apply this definition. First, let's unpack the definition. I think there are four important parts to this definition, even though it is long. A function is a set of input values called the domain, matched with a set of output values called the range. So 1, there's a domain. 2, there's a range, and 3, there's a matching, some sort of rule connecting domain values with range values. The fourth part is the most important part of the definition, and that's here in the last phrase, so that each element in the domain is matched with only one element in the range. If you think of your domain as x values and your range as y values, it's like saying that every x value is paired with only one, exactly one y value. This last part of the definition is what makes a relation a function. If I had stopped before that last part and just talked about a domain, a range, and a matching, that's called a relation in math, and that could or could not be a function. It depends on this last condition. So here is the test that we will apply when we begin to look at examples. Is each element in the domain matched with only one element in the range? Relations can be represented in different ways, as sets of ordered pairs, as a table of values, as a graph, as an equation, just to name a few. And the domain and range of relations can be finite or discrete, a countable number of distinct points, or infinite, like we'll see in number 3 and number 4, where the domain and the range are a whole interval or range of values. Let's evaluate each of these examples and test whether or not they are a function. So the first example, I have the points 1, 3, 3, 5, 5, 7, 7, 9. The domain value 1 is matched with 3, and only with 3. It's not matched with any other range value in this mapping. The domain value 3 is matched with 5, and only with 5. 5 is matched with 7, 7 is matched with 9. This is a function. Each element in the domain is matched with only one element in the range. I'd like you to contrast that with number 2, where we have 3, 1, 6, 2, 9, 5, 6, 3, 12, 4. So 3 is matched with 1 and only with 1. 6 is matched with 2. 9 is matched with 5. 6 is matched with 3. So there's a problem right here. The domain value 6 is matched with 2, but here the domain value 6 is matched with the range value 3. So that single domain is matched with two different range values. That contradicts our definition of a function. And so we say this is not a function. Now, how do we test a graph like this, where all of the x values aren't listed? In fact, there are infinite x values on this graph that are matched with y values along this line. It's often helpful to use something called the vertical line test. The vertical line test says that if any vertical line drawn through a graph intersects it in more than one point, that graph is not a function. Let's think about why this works. A vertical line on a graph represents a specific x value or a domain value. For example, if I draw a vertical line through x equals 1, that goes along with the domain value of 1. Now that vertical line crosses the graph in exactly one point right there. So this x value, 1, is matched with exactly one y value, and that point represents right where that matching occurs on the line. If any vertical line intersects the graph in more than one point, that means a single domain value is matched with more than one y value, and that would contradict our definition of a function. So because of the vertical line test, this graph is a function. And And finally, let's think about the equation y equals x squared. Since we have the vertical line test, it might be easier to represent this equation by its graph. If you recognize that x squared is the graph of a parabola, which looks something like this, we can test this graph using the vertical line test. So here's the graph. I draw vertical lines anywhere through this graph, and a vertical line will cross the graph in exactly 1 point, never more than once. So because it passes the vertical line test, this equation is also a function.